Good afternoon, everybody. I'm Kaustav Basu from Quby. I gave a lightning talk and a small demo yesterday. But what I will do today as well is I will introduce a little bit what we do at Quby, and then go a little bit on how we use our high resolution data or 10-second data capabilities to enhance and use it for smart meter data, which is more interesting for the community here. And at the end, I will also show that how you can use it to help utilities solve other problems. So let's go into the presentation. So what we have is we have a huge base of 350,000 connected home users across Europe. We have utility companies as our major partners, water companies, and even insurance companies. And it's all across Europe. Okay. So now I'll give you a small insight into the products and services we have. So we initially also the company started off as a smart thermostat company. So what you see on your left is the smart thermostat product, by which you can directly control your heating. Also, it's a smart thermostat, so you can program at what time you want your heating on, off, and all sorts of stuff. But it's not only that, you can also have real-time insights into your gas and electricity measurements, and you can do that through a remote app as well. So also what we provide is energy insights within the app. This could be from the data which is coming from the tone itself or the smart thermostat, or it can be coming from the smart meters, which will be the focus of the talk here. And also we have security packages and apps, which is kind of our IoT solutions we provide. So on the data services, if I talk about that, we have the waste checker, which I demoed yesterday, which is finding out waste coming from the appliances within your home, which generally works at the 10-second data level. You have also, we piloted a few projects on water insights. We have monthly energy insights also. We do currently are launching the bill breakdown, and there is also boiler monitoring services. Okay, so how does the data look and where does it come from? So Tone being a smart thermostat and being present within the house, you have first the gas and electricity measurements coming through the meter adapters. Then you can control all sorts of your peripherals within the house, so your Philips Hue lamps, your smart plugs, smoke detectors. You also have your, it of course speaks to your boiler to control your heating, and you can also have your solar panel connected to it and say its consumptions. But it's not only also that, because you also have all the click data coming from the app and your interaction with the Tone that also can help us build services for the end customers. Okay, so now most of you are familiar with this. So bill breakdown is something like given a total bill of your electricity or gas, how can you break it down into different categories? It might not be at individual appliance level, it could be at a group level, but it depending on the rate at which the data is available. Okay. So now let me go into a bit detail. How we use the 10-second data to make predictions for the 15 minutes data. So first what you see on your the top is the active power of 10-second data. So you see that the different appliances in this case can be recognized. But of course this is, you have, if you look, you have 4 cycles of washing machine. Within that you have the heat pump dryer, and finally you have a dishwashers. But generally a user is not that nice to you. He doesn't always start one after another his big appliances. He can also start them all together. So that makes, of course, the problem a bit harder. But generally, if you look below, it's the low resolution picture for the same house. So you do see that the information available at 15 minutes is not as not at the level you can have it for 10 seconds. So then how do we infer or make predictions at the low resolution data? So let us look. So because we have a high volume data for high resolution data, so it is around 350,000 users, we can use that to make reasonable prediction or estimates on the low resolution data, because for all the houses every day, we are predicting the appliances for high resolution data. And then following the comparison between low resolution and high resolution, we provide the service. I'll go into a bit detail in that. So what you have is for a P4 15-minute data, first you will do an estimation step, which is also discussed a lot in the morning, that you want to try an estimation step, but in the estimation at such low resolution, you can't get all the appliances. Huh? So you do need some kind of a stochastic measure or a prior measure of the other appliance categories present within the house. Mostly in literature, it's done through profiling of users, like, okay, you are 2-bedroom apartment with this and that categories. So what is the likelihood of you using kitchen appliance, etc. But we do it exactly data driven because we have high volumes of data available. And then given the two estimates, or one is the prior and what you have estimated, we try to make a good compensation and find the most likely distribution which is explaining the user's data. So let's go step by step. So first would be the estimation step, which is, I won't go into details. In the morning it was a lot discussed, but you have sequence to sequence modeling, or you can, so you run a subsequence time series detection of appliances, then you train a model, and you can have sequence to point learning, you can have sequence to sequence learning, and you make estimates of the energy of different appliances. So this is this works generally for white goods and stuff, but what you also need is that you, given a low resolution data, this is called, in general, in image processing domain, super resolution problem. So you don't really know the high resolution data, but you can infer the high resolution data from the low resolution data, and then use the prediction for the high resolution data as your prior for the low resolution data. I'll go into details if you have any questions on this, but this is the main principle on which it works. Okay, so now the architecture of such a model is like, so you have all the high resolution data coming from the thermostat, and then you have all the low resolution data which is also collected, and then they get into the Amazon cloud in S3. Then it interacts through Hive, and then you have every day it works with in the Databricks platform, and all the algorithms and all the results are calculated, which then go into the app backend, which is in DynamoDB in Amazon. And there is also not a lot, but anything which can be done within microseconds, that amount of intelligence is also present within the app backend to make some calculations given the user feedback and what the user is saying. And this is what the person sees in the app. So, and a brief to give you an idea how you can validate such models is like, one is we do have smart plugs. We did run control experiments across few tens or hundreds of users to get the smart plug data and try to match it with what is getting predicted to see how accurate you are. But we don't only do that. What we also do is for all our acceptance or test users, they do get an email app which we send them continuously every day, giving them the bill breakdown. And anytime they see some deviation from what they are expecting, they send us feedback, which is directly channeled into our Slack system. So it's just a very continuous way of developing, so that we don't deviate too much from reality. So to give you an idea, most of the distributions of appliance categories are within 5%, so plus or minus, so for each house. And okay, so now what are the building blocks for a live service? So what you see is what we discuss here a lot are algorithms, and the state of the art, and okay, we also have patented and published algorithms. But that's not only what is a main part of building a service, which is what I consider the algorithm is more like a kernel, but in and around it you need a lot of development. And so what are those things? First is you have to be privacy compliant. Then, with GDPR and stuff, then what you have is you need a stack of APIs which run on them. They have to be scalable. You have a huge amount of data coming in. You need all sorts of data pipelines, ETLs running. You need strong engagement with the customer, so you don't only show him a result, right? You need a tips engine. You need to continuously give him some advice with which he can act. And there is also the algorithms need continuous retraining from the feedback you're receiving, and also some intelligence in the app backend itself so that you can respond to what the user is saying as well. And also you need live monitoring. And the final thing is use case development and creation. So what generally our approach is not to show the end result, but try to solve some end user problems or utility problems. So what would be an example of this is, let me go back to our data. So because this is a community for NILM, I just showed you some electricity based solution, how you can use the capabilities of 350,000 10-second data users. But you can do the same for home insulation, for gas, for other stuff for which you have high volumes of data available, and with that make reasonable estimates for low resolution data, so that which is available from the smart meters. So this has been our approach. So, and that's all I have to say. So if you have any questions, I'm ready to answer. Thank you.